So today I'll be teaching about exponential functions. Uh, okay, let me. Okay, so what are exponential functions? Well, they are functions in the form of here sorry, f of x is equal to b to the power of x. Okay, so let me rewrite it here. Where b must be greater than 0 and b cannot equal 1. And why is that? Well, when b is equal to 1, um, if let's just say this were the graph, then this would be, or sorry, this would be the line. This would just be 1 to the power of x. K is just a horizontal line, and that does not that's not an exponential function. Okay, this would just be a linear function instead. So it cannot equal to 1, and if it were 0, then it would just be this line, or sorry, this line over here. This is so the when b is equal to 0, right? It would just be over here. It would just be the x-axis, and it would only be in the positive area. And once again, this is just a horizontal line, so this cannot be an exponential function. And then if it were 0, or sorry, if it were negative, for a negative number, I'm going to redraw the graph. So this would be f of x is equal to, let's just say, -2. Okay, let's just say the number was -2. Then this is what the graph will look like. So let's start off at the 0. So the origin, right? This is 0. This is 1. This is 2. This is 3. And then this is 4. If so, when x is equal to 0, anything to the power of 0 is just 1. So it would be here. This is the first point. And then if it were, and then at the x coordinate of 1, -2 to the power of 1 is just -2. So it'd be somewhere here. If it were, and then at 2, -2 to the power of 2 is +4. So it'd be somewhere up here. And then -2 to the power of 3 is -8. So it'll be somewhere down here. So as you can see, this is not a graph because like the points are not connected. This point is up here, and then this point is down here. So this is not a function at all. So that's why b must be greater than 0 and it cannot equal to 1. Okay, now moving on. So here, this is properties of an exponential graph. So we have f of x is equal to b of x. This is just a function. When b is greater than 1, this is what the graph looks like. It's just this curve right over here. And some properties or some important points on the graph. Right, so this part, this side here is -infinity. This side here is +infinity. Actually move something this way. And when x is approaching -infinity, so going this way, going towards the left, x is approaching -infinity, so it's just becoming a smaller and smaller number, and y is approaching 0. So over here, it looks like the graph or the line is on the x-axis, but it's actually not. It's because um, no matter what power you put uh, to a number, so like this graph is f of x is equal to 2 to the power of x. No matter how small of a number it is, so let's just say negative 1000, this is still a decimal. It doesn't matter how many zeros you add to the end, it'll always be a decimal. So yeah, that's the property of exponential functions. It never reaches the x-axis. And when we are going towards the right, this is an exponential function. So towards the y-axis, right? So the y value, so going up, this vertical line over here, the value increases very quickly. Okay, it grows exponentially. So let's take an example, right? 2 to the power of 0, that's just 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. You see the jump here is plus 1. The jump here is plus 2. The jump here is plus 4. So this increase, the amount this value increases, which is the um, y coordinate, it increases over time. So that is why when x is approaching infinity, so when it's so on the right side of the graph, y is also approaching infinity. Do we have any questions here? Okay, then moving on to the next graph. Okay, so this is where b is somewhere in between 0 and 1. Okay, so it's just some decimal or fraction less than 1. So if you're okay, and the pattern is like pretty much the opposite. So when x, so in the graph above, when x is approaching negative infinity, so this is still the same, right? This side's negative infinity, this side's positive infinity. Uh, it's just that in this case, when x is approaching negative infinity, it is for the y-axis, right? The y, it is going up, it is increasing exponentially. So comparing the two graphs, right? These two graphs are pretty much just like opposites of each other, right? This side, negative infinity is approaching 0, positive infinity is approaching positive infinity. This side is just the opposite. Uh, so let me rewrite that, right? So here, on the negative side, so on the left side, the graph is growing exponentially. It is going upwards. It's for the same reason as above. And then when the graph is going towards the right, it is approaching 0. Once again, same exact reason as the one above. Are there any questions here? Okay, moving on to the next part. Okay, so these are just exponential arithmetic rules. So when anything to the power of 0 is just 1, okay, it doesn't matter what number it is, as long as it is to the power of 0, it's just equal to 1. A to the negative n is equal to 1 over A to the power of n. So when it is a negative exponent, so in this case is A to the power of negative n, you can rewrite this as A over 1 to the power of negative n, right? Because any number to the over 1, so divided by 1 is just itself. So you can just write it like this. And when it is a negative number, or actually, And let me write it as this instead. Um, so when it is a negative number, you basically just move it down, right? You just swap its places. So in this case, a to the power of negative n is in the numerator of the fraction. So you just move it to the bottom. So now it is 1 over a to the power of positive n. Um, and so the point of this is just to make the exponent positive. And then in a different case, let's just say it was a to the power of negative n. So it's now, in this case, the a to the power of negative n is in the denominator. Right? In this case, you just move this term to the top, to the numerator. So this is just equal to a to the power of n over 1, which you can just write as a to the power of n. And then for the next part, this is here, a to the power of x, all this to the power of y. So a to the power of x to the power of y. This is just equal a to the power of the product of the two exponents, so x times y. This works no matter what. And yeah. And then for the next part, this is multiplication of two exponents. So a to the power of x times a to the power of y. This is equal to a to the power of x plus y. And this only works if the two bases are the same. Okay, so if in this case both are a, it's a to the power of some number times a to the power of some number. In this case, this works. If, let's just say it were a to the power of x times b to the power of y, this will not, this rule will not apply because a and b are not the same. Okay, now moving on to division. So this is basically the same, except now it is division. And this would be equal to a to the power of x minus y. Once again, this only works because the, a and a are both the bases. And this rule, these two rules are pretty much the same. It's just that this one's multiplication, this one's division. So this is relatively easy to remember. Multiplication is addition of the two exponents. This is division, so it is the subtraction of the two exponents. And then over here, this is a times b to the power of x, which is equal to a to the power of x times b to the power of x. Okay, so this is just, you're basically just putting an exponent onto both variables. And this only applies because of the brackets here. If it were a to the power or a times b to the power of x without the brackets, then this would just be the most simplified form. Okay, this rule will not apply. And then over here, it is a over b to the power of x. This is basically the same concept as the multiplication one. This is just a to the power of x divided by b to the power of x. Okay, and now for the last one, this is a to the power of the fraction. Okay, this is when the exponent is a fraction. So in this case, this is x over y. In this case, you take the numerator of the exponent, so x, and you can, so write down a, you take the numerator and you have it, you place it in the exponent as the exponent, and then the root sign, and you put the denominator here. Okay, so the numerator is always the exponent, the y is always the root. So if this were a to the power of 2 to the 2 over 3, you'll place the, so you can write a here, the 2, so you'll put the 2 here, so it's a to the power of 2, and then the root sign, and then 3 here. So this is, so a to the power of 2 over 3 is equal to the cube root of a squared. These are very important arithmetic rules that you must remember. So are there any questions here?
We're good.
Okay, then moving on to the next part. Okay, here the inverse properties of exponential functions. So the inverse of a exponential function is just a logarithmic function. Carol went over this in the previous class. So we have f of x is equal to b to the power of x. Remember, b is still, the same thing still applies. It must be greater than 0, and b cannot equal to 1. And the inverse is this. Okay, and you must put the -1 here. If you're to put the -1 over here, then this is just indicating that this is, you're basically making this x to the power of -1 instead of the inverse of the function itself. Okay, so the placement of the -1 is very important here. This would just equal to b to the power of 1 over x. This is the actual inverse, so log of base b of x. Okay, so yes, you must remember to put where you put the -1. And then over here are the, or sorry, over here we have b to the power of x is equal to c, and then we have this logarithmic over here. So we have b to the power of x is equal to c, and then we have log base b of c is equal to x. Okay, so the way, and as long as you know that one of these is true, then the other is true. So basically, these two equations are interchangeable. So we have c, so we have b to the power of x, right? The answer to that is c. This just equals to c. So remember that log is basically means what b to what power is equal to c, right? B to the power of x is equal to c. This is why log of base b is equal to c, or x, sorry. So you put the c here, you put, and then you have the base of the exponent b here. You place it as the base for the log, and then x is the exponent. You place it as the answer. And so you would just follow this pattern when you're interchanging between the two equations. Any questions for this? Okay.
Nope.
All right. Now we have algebraic exponential functions. Okay, all these rules, they look strange, but you must remember these rules. These rules over here, exponential arithmetic rules. Okay, following this is how you get your algebraic properties of exponential functions. So we have f of g. Okay, so f of x. So I need to. Okay. So f of x, this still equals b to the power of x, where b must be greater than 0 and b cannot equal to 1. And the product rule goes as follows. So let's just say that G and K are like real numbers. So F, so the function of G plus K. And these rules only work because you have the foreknowledge that this is an exponential function. Okay, so G plus K, this you can rewrite as F of G times F of K. Okay, and to prove that this actually works, right? F of G times F of K, this is B of G times B of K. And following the arithmetic rules, right? This is multiplication, so this is also equal to G plus K. And this is the same thing as you wrote over here, as I wrote over here. So in order for this to make sense, you must think of whatever is in these brackets as the exponent. Okay, whatever is in here is exponent. This is just a placeholder for the x over here. Okay, and now I'm going to erase this. Okay, now for the quotient rule. Okay, still using f of x is equal to b to the power of x. We have f of g minus k. Okay, so this, when it is a subtraction, when it's a subtraction sign, uh, you have f of g over f of k. Okay, it is always this first term. So in this case, g is the first term. So this is the variable that you put as the numerator, and then the k is the second term. So you put it as the denominator for the fraction. And to prove that this actually works, this is b to the power of g divided by b to the power of k. And once again, following the arithmetic rules, we have b, this is equal to b to the power of g minus k. And once again, it is the same thing here, right? Remember thinking of the g minus k as as an exponent. Okay, and finally, we have the power rule. So we have f of g, and we have this function of k. Now remember, this g is an exponent, meaning that you can basically move this k inside. So this is f to the power of, f of g times k. Okay, and this looks very strange, but you must remember to view the g as an exponent. And so in order for this to make sense, right, you have b to the power of g, right? I'm just rewriting this one. This is f of g, all this to the power of k is equal to b to the power of g, all this equal to k. And this is following the arithmetic exponent rules. This is equal to b to the power of g times k. So as you can see, it is the same thing written over here. So are there any questions here?
I think we're okay, Fred.
All right. And now I would like you guys to try these practice questions. Okay, write them down somewhere. I'll give you 3 minutes to do all of these. Okay, time is up. Uh, okay, uh, I'll write down the answers. Okay, so pi to the power of 0. Hopefully you remember that anything to the power of 0 is equal to 1. And for b, this is just a replication of what I had written in the arithmetic rules. So this is just equal to 1 over a to the power of n. Remember, this is a negative, and you want to make this positive, so you move it down. Okay, this is current. You can write this as over 1 to make it easier, and then you move the term to the bottom to the new to the denominator. Okay, and then this is equal to since it is 7 to the power of a, all this to the power of b is just equal to 7 to the power of a times b. This is, remember, I asked you to simplify. So this you'll write as 1 over 2 to the power of a, and 1 to the power of anything. Hopefully you realize that is just it's just equal to 1. So you can just write 1 over 2 to the power of a. Okay, this is the most simplified form. Over here, we have m times, or m to the power of n times m to the power of n. This is m to the power of n plus n. And since it's two n's, you can write this as m to the power of 2n. Okay, remember this is the most simplified form. And then over here, this is equal to a to the power of x times y over a to the power of w, which is a to the power of x times y minus w. And then over here, okay, over here, the way you would simplify this, okay, remember this bottom over here is a multiplication, this is addition, so you can actually rewrite this as two separate fractions. So 7 to the power of a over 7 to the 7 to the power of b times 3 to the power of c, and then this plus 3 to the power of b over 7 to the power of b times 3 to the power of c. Okay, and then this is, okay, so this is 7 to the power of a, 7 to the power of b, right? This is multiplication, which means that you can subtract the two exponents. So in this case, since we don't know which of the two exponents are larger, so we don't know if a is larger or if b is larger. So it doesn't really matter where you put it. Okay, I'll just put it at the top. So this is 7 to the power of a minus b all over 3 to the power of c, and then plus following the same logic. Okay, we don't know if b is larger or if c is larger. So I'll just write at the top again. So 3 to the power of b minus c over 7 to the power of b. Okay, this is the most simplified form. Of course, in an actual question, you would these exponents would have values to them, so you would actually be able to solve. But this is the most simplified form. And then over here, this is all to the power of c, but remember, BADMAS must do what's in the brackets first. Okay, so in this question, you need to realize that 9 is actually 3 squared, right? 9 is equal to 3 squared. And so 9 to the power of b, right? 9 to the power of b is equal to 3 to the power of 2 over, or to the power of b. And then, so this you can write as 3 to the power of 2 times b. So right here, this is 3 to the power of a times 3 to the power of 2b over 3 to the power of b, all of this over to the power of c. And this is subtraction. 2b minus b is just 1b. So this is equal to 3 to the power of a times 3 to the power of b, all to the power of c. And then you basically add the two exponents, and then you also multiply all the exponents by c. So this is just because I don't have enough space here. This is equal to 3 to the power of AC plus BC. Okay, this is the most simplified form. And then over here, so what's 4? 4 is equal to 2 to the power of 2. B, or 8 is equal to 2 to the power of 3. Okay, that's what you needed to realize in order to do this question. So this is 2 to the power of a times, this is 2 squared, all to the power of b. So this is 2 to the power of 2 times b. All this to the power of c, and then divided by 2 to the power of 3 times d. And then this you can rewrite as, sorry, what just happened? Right here, this is 2 to the power of AC plus 2BC, all divided by 2 to the power of 3D. And then over here, you just subtract. So 2 to the power of AC plus 2BC minus 3D. This is the most simplified form. And then over here, in order to do this question, right? What's 6? 6 is 3 times 2. Okay, so this is 3 to the power of a, sorry, brackets. Or you can actually get rid of the brackets because you have, this is just multiplication division. So you can get rid of the brackets. So this is 3 to the power of a times 3 times 2 all to the power of b divided by, and then 8. We already said over here, 8 is equal to 2 to the power of 3. So this is 2 to the power of 3 times c. Okay, now you distribute this exponent. So 3 to the power of a times 3 to the power of b times 2 to the power of b divided by 2 to the power of 3c. Okay, remember, like terms, the space over here has to be the same for the arithmetic rules to apply. And 3 and 3, 2 and 2. So the way you do this is 3 to the power of a plus b. Okay, this is for the terms with 3 as the base. And then times 2 to the power of b minus 3c. Okay, this is just for the terms with the 2. Okay, so this is the most simplified form. Any questions here?
Nope.
Okay, then moving on. Now that you guys seem to be more or less okay. So this is an math contest problem, but this is just solely using exponential arithmetic rules. So I will give you guys 2 minutes to do this. Okay, try it out. If you can't, then follow along as I explain how you do this question. Okay. Okay, 2 minutes is up. All right. So the question is, suppose that 4 to the power of A is equal to 5, 5 to the power of B is equal to 6, 6 to the power of C is equal to 7, and 7 to the power of D is equal to 8. And they're asking uh, for the product of A times B times C times D. Okay, so uh, as you can see here, yeah, the answer is B. Um, okay, so we have, since 4 to the power of A, right? They give you this. They give you 4 to the power of A is equal to 5, right? Since 4 to the power of A is equal to 5, you can sub that into this equation right here, right? You can put this 4 to the power of A, and you can sub it into this 5 over here, right? So then you get 4 to the power of A, all that to the power of B is equal to 4 times AB, which is equal to 6. Okay, now you have uh, A times B, right? You see this pattern over here. So, and then you repeat this pattern until you get A times B times C times D, right? So now you have 4 to the power of A times B is equal to 6. So now you can sub this in to over here, right? Now you can sub it in for this 6 over here. So 6 to the power of c is equal to 4 to the power of a times b, all that to the power of c. And now you have 4 to the power of a times b times c is equal to 7. And then same thing applies for the 7 over here. You can sub it in for this 7 over here, right? You can sub this exponent in for the 7. Okay, and then you get uh, have all this. You get 4 to the power of a times b times c times d is equal to 8. And 4 and 8 are both powers of 2, right? You can express them as powers of 2. 4 is equal to 2 to the power of 2. 8 is equal to 2 to the power of 3, right? So now you can rewrite this equation over here, right? This specific equation. So we have 4 to the power of a times b times c times d is equal to 2 squared times all this. And so you end up with this over here, right? You have 2 to the power of this exponent. And what you want to do is, right, and you have this is equal to this, right? That's what is implied in this equation over here. So therefore, we have 2 to the power of 2 times ABCD is equal to 2 cubed. And since the two bases are the same, right, it's 2 to the power of this times 2 to the power of this is equal to 2 to the power of 3. So we can conclude that the two exponents must be the same. So 2 times ABCD is equal to 3, and we're looking for ABCD, right? So we move the 2 over, we divide both sides by 2, right? That way we cancel out this 2 over here, so we get rid of this 2, and we get ABCD is equal to 3 over 2, and so that is why the answer is B. Okay, do we have any questions? Please
No,
ask if you do. Okay. And then, okay, skipping this one. Okay, now we have this question over here, right? Suppose that 4 to the power of x1 is equal to 5, 5 to the power of x2 is equal to 6, 6 to the power of x3 is equal to 7, so forth, right? All the way until 127 to the power of x 1 to 4 is equal to 128. Okay, now it is asking for what is x1 times x2 times all the way to x 124. Okay, we are basically using the same exact thing as we did in this question over here. Okay, same exact thing except with much larger numbers. Okay, uh, I will give you guys 2 minutes again to do this question. Okay, the 2 minutes are up now. Okay, so we have this question over here. I'll reread it. Suppose that 4 to the power of x1 is equal to 5, 5 to the power of x2 is equal to 6, so on and so forth, all the way until 127 to the power of x124 is equal to 128. They're asking for this right here. What is the product of this? Okay, so the way that you do a question like this is you need to find a pattern, right? The reason why it is such a large number is because there must be a pattern of some sort. And the pattern here is, so we first have 4 to the power of x1, right? 4 to the power of x1 is equal to 5. And we have 5 to the power of x2, right? We can sub in, same thing as before, right? 4 to the power of x1. We can sub that in for 5. And we get 4 to the power of x1, x2 is equal to 6. Right? And we can follow this pattern. Right? And if you don't believe me, well, we have 6 to the power of x3. Right? We are subbing in this. So we have 4 to the x1, x2, all this to the power of x3. This is 4 to the power of x1, x2, x3 is equal to 7. Right, so you can see, as you can see here, we can use 4 as the base for all the numbers. And so that is why in the end, by following this pattern, we have 4 to the power of what we want to find, right? x1 times x2 all the way until x124 is equal to 128. And so, and we want to further simplify, right? We want to make our life as easy as possible. And so hopefully you realize that 4 is equal to 2 to the power of 2. Okay, so we get 2 to the power of 2 times x1, x2, all the way till x124. And 128 is actually a power of 2, right? It is 2 to the power of 7. Okay, this must all be like intuitive in order to save as much time during a math contest as possible. And so let me clear. So we have here, therefore, we have 2 to the power of 2 times x1, x2 all the way till x124 is equal to 2 to the power of 7, right? Since we have 2 as the base for both, that means that the two exponents must be equal. Okay, so once again, same exact thing as the previous question. And so we have 2 times x1, x2 all the way until x124 is equal to 7. And we just move this 2 over to the other side, or we just divide both sides by 2 to cancel out this 2. And we are left with 7 over 2. So the answer must be D. D 7 over 2. Hopefully that makes sense. It is now 12:59, so I guess we can end here.
Wow, good job, friend. That